Now we are discussing about two transistor model of SCR. We already discussed SCR is a 4-layer, 3-terminal, 3-junction device. Now we are discussing SCR as two transistor model. We are trying to understand SCR with the concept of two transistors. This is a P-type region, P layer. We are representing the N layer with a small division. This is one N-type region, this is one N-type region, this is one P-type region, this is one P-type region. So now this is appearing like a PNP transistor and it is an NPN transistor. So in PN 4 layers, we are observing two transistors. One is PNP, second one is NPN. This is PNP transistor and this is NPN transistor. Remember, these two N regions, even though they are appearing like they are separate, but they are electrically connected because of course they belong to the same N region. So that's why we are representing this arrow symbolizing that these two N regions are electrically connected and these two P regions are electrically connected. This is a PNP transistor and this is a NPN transistor. The anode, cathode, gate terminals we have represented. Now we are representing this by using the circuit symbol. The two transistors are Q1 and Q2. Now this is the anode. Here for this transistor Q1, the anode current is nothing but emitter current because this is PNP transistor. And for this transistor, the cathode, here the emitter current is nothing but the cathode current. We have anode current, that is the emitter current of the first transistor. We have cathode current, that is the emitter current of the second transistor. And here we have gate current. We already knew the collector current IC is equal to alpha IE plus ICBO. The collector current is nothing but a fraction of emitter current and the leakage current. Means when we are open circuiting the collector and base, whatever the current we are observing, that is ICBO. We are having two transistors. For the first transistor, IC1 is equal to alpha 1 IE ICBO. But we already knew for the transistor 1, emitter current is nothing but anode current. So alpha 1 IA plus ICBO. And we already knew for the second transistor, IC2 is equal to alpha 2 IE2 plus ICBO2. The second transistor emitter current is nothing but the cathode current, IK plus ICBO2. This is IC2. This is equation 2. In SCR, the current is always observed from anode to cathode, unidirectional current. When we do not give any trigger to gate, there is no current flow from anode to cathode. When we trigger the gate, at that time only current will be there from anode to cathode. So whatever the current we are observing now here, whatever the current we are now observing here, this anode current, this is splitting into IC1 and IC2. Whatever the small current here we are giving, whatever the small base current you are observing here, this IB1 is IC2 for the second transistor. When we are giving a small gate current, that will enhance the IC2, thereby IB1. This will be running in the loop. Now, IA is equal to IC1 plus IC2. And when gate is triggered, therefore IA is equal to, what is IC1? Alpha 1 IA plus ICBO1 plus alpha 2 IE2 plus ICBO2. When gate is triggered, the cathode current IK is equal to anode current IA plus gate current IZ. Therefore, substituting the equation number 4 in equation 3, when we want to substitute here, this IE2 is nothing but the cathode current IK. So I am substituting this IK here. Now the IA is equal to alpha 1 IA plus ICBO1 plus alpha 2 into IA plus IZ plus ICBO2. This is the final expression, and after that IA is equal to, I am taking common IA, alpha 1 plus alpha 2 into IA. This is alpha 1 and this is alpha 2 plus alpha 2 IZ plus ICBO1 ICBO2. Now when we take the IA to the IA term to the left hand side, IA is equal to 1 minus alpha 1 plus alpha 2 is equal to alpha 2 IZ plus ICBO1 ICBO2. Therefore, IA is equal to alpha 2 IZ plus ICBO1 plus ICBO2 by 1 minus alpha 1 plus alpha 2. This is the final expression. But in order to turn on the SCR, this alpha 1 plus alpha 2 should be nearly equal to 1. When this is nearly equal to 1, the denominator becomes 0. That means IA is equal to infinite. SCR is turned on. So we will make sure that alpha 1 and alpha 2 value must be almost, that should be equal to nearly 1. So alpha 1 we maintain less than 0.5, alpha 2 we maintain less than 0.5. Generally alpha range is from 0 to 1, but we are maintaining alpha 1 value nearly 0.5. We are maintaining alpha 2 value nearly 0.5, such that these two transistors will make the SCR to turn on accordingly. This is the two transistor model of thyristor. We represented the thyristor by using two transistors. Operation is same. We are explaining this concept by using the two transistors.